is P comma Q. Yeah, couple of coordinates, right? A point in the line y equals 2x plus 3. Yeah, this is like a very normal expression to represent a line, linear equation with two variables. And you have two statements. The first one is this expression, a product of two expressions involving P and Q equals 0. And the second is similar, right? Yeah, with a few differences. And that's it. How could we approach this question? Just a minute to think it over. Something we can say about this question is that there are no patterns here to actually try and visualize this geometrically. Well, just one thing, right? If a point belongs to a line, then it must satisfy the equation of the line. If P comma Q represents a point in the line with the equation indicated, then substituting the coordinates of that point into that equation should yield a true equality. In other words, if you were to substitute y for q and x for p, you would obtain this, right? Okay. So q equals 2p plus 3. If this were true, the answer to the question were affirmative, then this equality should be true. In other words, the original question is equivalent to asking, is q equal to 2p plus 3? But then, just being a bit observant, you know, the expression in the first factor of statement 1 and the second factor in statement 2 looks a lot like this. Why? Because if you place q on the right side of the equality, this becomes, this is equivalent to asking whether 2p take away q plus 3 equals 0. That is the true question. Notice, this is precisely the expression appearing here and here. So, is that expression equal to 0? Can you tell from statement 1? So, we'll deal now as if this were the true question. Actually, it's equivalent to the original question. Determining whether that expression, 2p less q plus 3 equals 0, is the same as giving an affirmative answer to the original question. And vice versa, So, what about statement 1? You have, a basic structure that looks like this, x times y equals 0. Yeah, you can analyze from this basically that either of the two factors may be 0, but do you know which? All we can tell about statement 1 is that it means that 2p minus q plus 3 equals 0, or 3p plus q minus 5 equals 0. If this were a possibility, actually it is a possibility, if this is true, then this means an affirmative answer to the question. But what happens if this is true? If this is true, the second possibility, is it necessarily true that 2p minus q plus 3 equals 0? No, because that would be the same as saying, pick two values for p and q that make this true. And then, would those arbitrary values would necessarily make this, true? No, unless you solve this kind of equation system. If you solve this system, you would find the two values for p and q which make not only this true, but also this true. But what about any other values of P of Q and Q that do not concur with the solution to this system? Just two values that would make the first equation true. In those cases, you would get a no for an answer to this question. So the first statement is clearly insufficient. What about the second? Well, it's the same thing, right? Now you see that this expression appears as the second factor. So this means that either 3p plus q minus 7 equals 0 or 2p minus q plus 3 equals 0. If this were true, then we know that this means an affirmative answer to the question. But here, this one being true doesn't mean necessarily that P and Q will make this question true, or this equality in the question true. Because you can pick the values of P and Q that precisely make this 0 and this 0. Notice it's an or you could pick just two values, P and Q, that make this 0, but don't make this equal to 0. So in that case, that this is true means that you can have yes or no for an answer. Same as in this case. Yes or no, it's possible considering the second possibility. So that's why the second statement is not sufficient. So we are forced or compelled to analyze the two together. Any questions? Any doubts? Gabriel, did you see why B, or the second choice, is not sufficient? Or you have still doubts?
No, I already solved it. Both together are sufficient.
All right. Yeah, thank you. So, take a look what happens, people, when you take the two statements to be together. Together true. Well, basically, it means that 2p minus q plus 3 could be 0, or 3p plus q minus 5 could be 0, or 3p plus q minus 7 could be 0, or the other factor, which is the same, 2p minus q plus 3 could be 0. How do we analyze this? Let's simplify the whole thing like this. You have this, xy equals 0 and xz equals 0. People, can you tell me from these two equalities being true at the same time whether x is 0 or not? Can you tell? Who wants to argue on this? If x and y equals 0 and x times c equals 0, Gabriel, please.
Well, in that particular example, it would be not that clear if x is 0, because j and z could be 0 independently. They could be the same variable, but just two different names for it. But in the
No.
example,
We are talking about three variables, not the same variable. But okay, I understand your point. If y and z were 0 at the same time, that would release x from being necessarily 0. For example, if y were 0 and z were 0 together, then x could be anything. So that means that x doesn't have to be 0. Just from this, you don't know whether x is 0 or not. But let me add one more condition. So, if to these two equalities, I add this one. Can you tell whether x has to be 0 or not?
in that case, yes, x has to be 0.
X has to be 0, because imagine the situation where y would be 0, which is a possibility, right? If y were 0, since z has to be different from y, then z cannot be 0. That would make compelling for x to be 0 if this equality has to be true. You know, the other way around. Imagine that z were 0. Well, that would make this equality true. But since y has to be different from z, y cannot be 0. If y is different from 0, the only way for this to be true is that x is 0. So the idea is that this condition compels, that x be 0. This is similar to the analysis of statements 1 and 2. Imagine x being 2p minus q plus 3 and y and z the other two expressions, 3p plus q minus 5, 3p plus q minus 7. We know from the particular shape of these expressions that these expressions, the expressions other than 2p minus q plus 3, they have to be different. Why is that? Well, notice they have a common part and then a different term. No matter which values of p and q you may pick, these two expressions will never have the same value because 3p plus q is the same number, right? It's a number like n. So n minus 5 is never the same as n minus 7. These two expressions will always be different, same as here. Since they always have to be different, no matter if one of them is 0, since the other has to be different, then that makes compelling that the other factor, that is the like of x, 2p minus q plus 3, it has to be 0. It has to be 0 for the two equalities in the statements to hold true. All right? So that's the point. You can pick, whatever values for p and q that make 2p minus q plus 3 equal to 0. There are infinite pairs, of course. Yeah, but what happens when you pick a pair of values that just makes 3p plus q minus 5 equal to 0? Well, that pair of values could or could not make 2p minus q plus 3 equal to 0, right? But if you have a pair of values that makes p plus q minus 5 0, you are sure that 3p plus q minus 7 cannot be 0. That forces that the other value or the other factor has to be 0. So necessarily, the possible values for p and q, considering the two statements together, have to be two values that make 2p minus q plus 3 0, or two values that make 3p plus q minus 5 0 and at the same time 2p minus q plus 3 0, or two values that make 3p plus q minus 7 equal to 0 and at the same time 2p minus q plus 3 equal to 0. Those are the only possibilities. So in all cases, considering this, the expression here has to be 0. Therefore, C is the correct choice.